You sneezed last spring. Your eyes burned, your nose ran for hours, your throat felt raw every time you swallowed. Maybe your skin broke out in a rash. No bite, no contact, just red and itchy for no reason at all. Pollen did that. But pollen can't hurt you. It's a speck of plant dust, smaller than a grain of sand, completely harmless. Your body attacked it anyway, not because pollen is dangerous, but because your body mistook it for something else. Something that lived inside every ancestor you've ever had. In you, it's gone. To find out what it was, we need to look somewhere most people would rather not. In labs around the world, researchers keep shelves of coprolites, fossilized human feces, some older than the pyramids. To study one, you take a chunk that's been bone dry for millennia, shave off a slice thinner than a fingernail, and slide it under a microscope. The shapes come into focus slowly, ovals with ridged shells, some still holding the faint curl of a larva inside. Parasite eggs, sealed in something a human passed before writing existed. When the light hits them, they look almost new. Clean ridges, sharp edges, as though they were laid yesterday, not 5,000 years ago. In 1991, hikers in the Italian Alps stumbled on a body frozen in the ice. He'd been there for 5,300 years. Scientists called him Ötzi. When they examined what was left of his gut, they found whipworm eggs, Trichuris trichiura, one of the oldest confirmed cases of this parasite inside a human body. But Ötzi wasn't special. He was normal. From sub-Saharan Africa to northern Europe to the tip of South America, nearly every ancient human that's been examined carried parasites. The easy story writes itself. Dirty water, no hygiene, brutal lives. Ancient people suffered with worms because they couldn't get rid of them. That story has a problem. It wasn't just that ancient humans carried worms, it was how many kinds they carried at once, and how little damage they did. At a site in Brazil called Gruta do Gentio II, researchers examined human coprolites and found 5 separate parasite groups in a single sample. 5 groups, sharing one gut. And these people rarely died from it. They lived with worms for decades. They walked for miles every day, hunted, gathered, raised children, survived droughts and winters and each other. For tens of thousands of years, generation after generation, humans carried parasites and kept going. When everyone has something and almost nobody dies from it, that stops looking like a disease, not an infection, something else. So if it wasn't an infection, what were the worms actually doing in there? Parasitic worms don't just sit in your gut and feed. They secrete molecules, specific chemical signals, that dial down your body's inflammatory response. They quiet the immune pathways that would otherwise attack them. For years, scientists assumed this was purely selfish, the worm dampening your defenses to avoid getting expelled. But the calming doesn't stop at the worm. It spreads. Researchers studying parasitic nematodes found a molecule called ES62 that directly shuts down the signaling pathways behind inflammation. The worm wasn't just hiding from your immune system. It was turning down the volume on the entire thing. This wasn't a glitch. It was co-evolution. Your body and the worm adjusting to each other over hundreds of thousands of years. Your immune system didn't just tolerate the worm, it relied on it. The worm released signals. Your body read them. Together, they kept inflammation in check, a conversation that had been running longer than spoken language. Pull one side out, and the other side doesn't know how to stay quiet. It keeps running hot. Now go back to the beginning. Your body mistook pollen for something else. Now you know what that something else was, a calibrator. Something your immune system was built to find, because for as long as humans have existed, it was always there. Your body isn't broken. It's tuned for a world that doesn't exist anymore. They weren't invaders. They were regulators. And the system they regulated? It wasn't some minor subroutine. Your immune system doesn't have one lonely cell on worm duty. It has an entire branch. Its own dedicated cells. Eosinophils, basophils, mast cells, a whole class called ILC2s, its own chemical signals, its own antibody, IgE, an entire division shaped over millions of years of evolution for one job, managing helminths. Think of it as a standing army, trained, staffed, fully funded, and the war it was built for ended overnight. Except nobody told the army. So it keeps finding enemies. Pollen, dust mites, peanut proteins, the lining of your own gut, the sheath around your own nerves, allergies, asthma, Crohn's disease, multiple sclerosis. When you lay the maps on top of each other, where these diseases hit hardest and where parasitic worms still live, they almost perfectly invert. Where worms remain, autoimmune disease is rare. Where the worms were wiped out, the diseases surged. Correlation isn't proof, but the correlation is striking. For the entire history of our species, your immune system had a partner. In 2003, an immunologist named Graham Rook gave that partner a name. He called them old friends, the organisms we evolved with that weren't just passengers. They were part of the machine. And in the space of a few generations, a blink in evolutionary time, we ripped them out. The question was never how they dealt with parasites. It's how we're dealing without them. Your parents ate whatever they wanted. Their children can't touch half the menu. Your grandparents had never heard of a peanut allergy. Nobody in their school carried an EpiPen. No birthday party came with a list of foods you weren't allowed to bring. One generation, that's all it took. Now walk into any elementary school. Between 1997 and 2008, peanut allergies in American children tripled, from 0.4% to 1.4%. In the UK, rates jumped fivefold between 1995 and 2016. Food allergies that barely existed a generation ago are now everywhere. Millions of people across every developed country all at once. An entire generation whose bodies lost their calibrator. Modern medicine spent 100 years wiping out parasitic worms. Soap, sewers, deworming pills, clean drinking water. We fought them across every continent, and we won. By every measure we had at the time, it looked like one of the great victories of modern civilization. In 2005, gastroenterologist Joel Weinstock gave 29 patients with active Crohn's disease a dose of 2,500 pig whipworm eggs to swallow, a close relative of the parasites we'd spent decades eliminating, chosen because it can't survive long in a human gut. Every 3 weeks for 6 months. After 24 weeks, 21 of them, 72%, were in remission. We spent a century getting the worms out. Now we're swallowing them on purpose.